All right. Well, it's a little after 7, so I guess we can go ahead and get started. The plan was start at 7 o'clock. We're gonna start a few minutes later so some people can get settled in. Let's get started with me introducing myself. My name is Ian Oberdorf. I'm a Bachelor of Science from in Computer Information Systems from DeVry University. I graduated in 2019. Currently, I work as an electrical engineer for Mettler Toledo. I do plan to head back to college here soon to actually get a double E degree. Um, might be with DeVry, might be at Ohio State. I'm not 100% sure on my thoughts here yet. But kind of prep this workshop so that we can have a little fun with programming and design concepts. Painting this program in this workshop, we're not really going to be doing any actual programming. This is more like the planning phase of things. So designing databases, it's kind of important that you do some planning and laying out of your database and what's the end project going to be. Now I will say that I wouldn't really be able to get this far without having taken the course from DeVry in Introduction to Databases, I believe is what it was called. My professor at that time was Gina Cooper, who actually she helps out the IEEE today, and she was actually one of my favorite professors when I was at college. Apparently, she is not joining us today. I was hoping she would. That would have been nice. But let's go ahead and get started. So for this workshop, we're going to kind of be playing off of the scenario being a pharmacy. So it's a brand new startup pharmacy. They do not have an application built that would manage their systems yet. So they are looking to be just like a normal CVS pharmacy or Walgreens pharmacy. They plan to sell everything. um, so we're going to kind of fix this up like it's a store, but it's also going to be tracking patients and staff members, all kinds of things. So it's going to be kind of a big database to develop, but um, big databases are kind of why we created this stuff. So one thing you might be wondering, why do we have Excel up? Well, Excel kind of was used as an original database in the beginning. Pain with Excel is it doesn't really have a really good entity relationship setup. I mean, there are ways you can do databases with Excel, but that's also where Access got produced. Access is a database tool that relies on SQL to actually store data. But Excel, for those that don't have access to databases, is kind of the go-to. So generally in Excel, say we're trying to plan a party here today, and we're trying to keep track of who all do we have in our attendees list. Well, generally we could be filling out all kinds of information, like we're going to collect everyone's names. So your first name, if you're IEEE members or this is an IEEE event, we're going to be collecting your IEEE number. So if you are an active IEEE member, you would have an IEEE number associated with you. This could also work for a staff member or something. So we could just say the ID number. Then we could also say what is your probably we're trying to collect data for sending a mail list. So optional information being like your house address. Then you have your email address, so you can get added to our email list. Then we have your, let's say, what else could we add in a nice little welcoming message? What is your city? What's your state? And what is your zip? So let's say we started out with just this simple information. In this case, there is actually a way we could utilize a database to make sure that we're not eating up too much space. First, we want to be looking at what's commonalities in here. First off, everyone's going to have a unique ID number. What is their membership number? Secondly, names. Everyone's going to have a different name. and that name is usually going to be associated with an ID. Everyone's going to have a different house address. Everyone's going to have a different email. But multiple people might reside in the same city. They'll also reside in the same state. And then a lot of times the zip will be the same. So one thing we could do in this situation is, rather than have them enter all this information every single time, we could make it where if they just entered the zip code, then this information would be populated. That's kind of where databases could come in. I could take the city and state and I could cut those out, and they could be in a whole nother table. And this table would be our zip code table. Let's drag these over one so we can put our zip as the first object. So you would enter your zip code, then we have our city and state. So what would happen is when our user enters data, they enter the zip code. What would happen is the zip code would now look over to the second sheet and say, okay, what's your city and state that resides with you? That's where entity relationship happens. Entity relationship is the relationship between two tables through a single entity. And in this case, the zip code. Now, say I was also going to assign a table that only kept track of our names. Meanwhile, I want to keep track of our house and email in another table. Well, we could have, if we take the ID, the house address, and the email, and we copied that data, and we put that into another table, we could have our personal information. So communications info. We call that the communications table. So I hope I'm kind of getting you guys started on what all you can do already. As you see, we're already eliminating a lot of fields and making this one Excel document turn into multiple tables that will have entity relationships. So that's kind of one way you can do it. Another way, like I had told Bryant, and I also mentioned before we started, is to use a tool called Visio or to use what's called Lucid Chart. Visio usually it is an extra in your Office 365 applications. I believe if you don't have an enterprise account, Visio is not included. So Visio, I believe, costs $14.99 a month if you don't go on that path. But Lucid Chart is a cloud application, so a web-based application that is currently about $7 a month. But until you use so much data, you actually have the option to use it for free. So, and yes, if you are a DeVry student, you do get Visio for free. Thanks, Brian. So let's kind of cut from how we're kind of exampling just simple everyday data that we'll be using. We're going to start focusing on our end goal here, which is this pharmacy. We're going to imagine what all goes into our pharmacy. What type of data do we need to keep hold of that would be important? So first off, we're going to probably want to consider we're going to have people. So we will have lots of people. And that's kind of where some of this information will come in handy. So we're going to consider staff members. We're going to consider the customers, and we're also going to be considering our pharmaceutical patients. So the patients that are actually coming for prescriptions and such. So what we can do for that, we'll go on table 1 here. We're going to try to consider all fields of data that we could possibly use in this pharmacy. So let's start with every single individual. They are going to need to have an identifier, so a unique a unique identification code. Okay, so UUID. And that would generally be a number consisting of just however you want to set it up. So this is more like a record keeper. So in IEEE, your membership number, this would be your UUID. So in my case, we could say UUID, we have user number 5. User 5, they're going to be, this user number 5 will actually connect to other tables and get us their information back. Okay, so we have a UUID for the customer. Then we're going to want to consider their name. So first name, last name, how you do it, it's up to you. You can have them both in one single field, or you can have them in separate fields. How you go about it is up to the data designer. So we could have first name and then last name. So I call it first and last. Then we could have, like I was saying earlier, your email address, phone. What else do we have? Phone number. We have. Let's think. What else could they have? They have RX numbers. Sometimes in pharmacies, you have your pills. Those are going to have a special pharmaceutical number. So you could say RX number. All right. And then we could also say your. Let's just start with this stuff, and then we're going to go off to how I like to make it. Because honestly, this method is kind of one of the methods I learned when I was in class. Is you're supposed to start with an Excel document, jot down every single possible field you would need to make a database, and then go through that and pluck out the tiny little pieces that will give you what you need. So, what little pieces in my data, in my information that I've already decided I want to use, can I pluck from and say, okay, well, you're going to have a relationship with this on multiple ways. So that's kind of a one-to-many relationship, which I'm about to show you. Why do I not like this method? It's just because I can't really visually see it, and sometimes I'm just constantly thinking, I'm like, oh, that should be in that table, that should be in that table. So every time I come up with something, I'm like, what table should it be? Does that table exist yet? How about I make a table? So that's where Excel kind of comes out of the picture. In this case of our pharmacy, RX number, one customer is going to have a lot of RXs. So what do you think is going to happen with all this? This data just got turned into 50 lines. And that's not what we want. We don't want 50 lines of data for the same customer. Like, we don't want to have their name constantly repeated. We'd rather it just be one unique identifier that carried all this information in one table, and then another table will share that unique identifier. When I call out for that patient, it'll show me all their RX numbers. So that's kind of what we want. It's kind of like as students, you guys all are taking different classes. Do we want to have a table like this where everyone is we're gonna see class 1, class 2, class 3, class 4, class 5, class 6? Or are we gonna see first name, last name, class taken? And then we're gonna have that just constantly repeated. Every time you take a class, a whole new record line is gonna be created that says what class you took. No, that's where the D number comes in, if it's still called a D number today. So when I was in college, we called it the D number. That D number holds your records to where on one table it's going to have, one table it's going to have your name and contact information. Meanwhile, on another table, it's going to have a history of what classes you were taking. Another table might say, what's your major? So all that stuff compiles into different tables to save data. Otherwise, we're going to have something like this where we're going to have the same thing constantly repeated every single time. Name, 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 name. It's the same name 20 times, just every line has one thing that's different. Wasted space, waste of data, waste of servers, waste of energy. So let's move on to my method because it's a lot more visual and a lot easier to understand. I kind of wish the professor would, the classes actually just went with this method first, but they were designed in special ways because this is what I just showed you was one original method. So Lucidchart and Visio, you have something called entity relationships, and that's generally what databases are. And I've said it multiple times. Generally, when you start Lucidchart, you're not going to see those entity relationships at all. They're not going to appear here in our list of shapes to use. So what you would have to do is whatever visualization tool you're using, flowchart tool or whatever, you go down to your shape library and find entity relationships. And as you can see with the paid edition of Lucidchart, you have access to a lot. So including like AWS architectures, you have access to database designs in a way, which we're kind of doing. But this is more like AWS stuff. So all these are AWS tools. And AWS is probably going to be another workshop we'll do here in the future. So I'm not going to point that stuff out. Azure, this would be handy for your class and databases, but I don't think it has really a need in the class. The main thing you would need for the class is your entity relationship. So just choose entity relationship. It's universal for anything you're using. Just click that check mark, use selected shapes. So back to our pharmacy scenario. Let's make our first table being the humans. So this table, we're just going to call, because this is going to be our doctors and our nurses and our patients and all. So we're going to go ahead and call this one our people. So this will be our personnel and our staff members. So first thing we need to consider, and another thing I want to do is get rid of that table and use this one. Why do I use this one? Because it actually tells me keys. So let's go with people again. Now, all our people, we need to give them unique identifiers, like I said, and this is going to be how your record is carried. So give everyone that unique number. Now, one thing I don't think I mentioned, and that's why I pulled this table up, is keys. So I said a key. Generally, there's 2 keys that I only pay attention to. I know there's a lot more keys for those that are already in databases or higher advanced in databases than I am. But the prime keys you need to understand are foreign key and primary key. A primary key is the unique identifier of the table. Okay, so every record should have a primary key that can be called upon from another table. And that's kind of why I said everyone's going to have that identifier. So we're going to put the ID field, and where it says key here, I'm going to say a PK. So generally, a primary key is just a PK. Next thing, we got, of course, our names that we were talking about. So I'm just going to go ahead and we're going to have everyone have a first and a last name, because generally, when you're filling out that information form, you got the first name, last name. You could do first name. Also, here's another thing. When you're designing your database tables, you should know about what's called camel casing. Okay, so camel casing is used in programming a lot, and it's generally because when you add a space, another variable or function is expected. So camel casing, what you're going to do is the first letter of every word is going to be capitalized. So in this case, I could write first space name, but the database isn't going to like it. So if I want to stay constant with the database I'm designing, I want to make sure I use camel case, or I just make it just one solid word. So first name, I'm going to just erase the key factor here because there is no key comment or no key associated with a first name. Okay, last name, same thing. Okay. Get rid of these notes because they're not needed. All right, so we kind of have the basics. First name, last name. That's good to start. We'll add more to this table here in a minute. I want to go on to the foreign key and the primary key relationships. So we're going to go, let's go towards the prescriptions. Okay, so obviously we're going to have people that have prescriptions in this pharmacy scenario. So let's do pharmaceutical records. Let's go with a table here that's going to be pharmaceutical records. And what this table will be, we'll have this table's focus be the information of the prescription. So this isn't going to be when did you pick up your prescription. This is just going to be, okay, who's the doctor responsible? Who is the patient? Who is, or I'm sorry, what is the prescription? What is the dosage? how long are they supposed to have this to? When does this prescription expire, et cetera, et cetera. So, pharmacy records, first thing, let's go with the record number. So, RX number. If you have a CVS bottle with you right now, you know that you have a number that is unique to you, the RX number, and that RX number is associated with this field. And what's going to happen is when I call the pharmacy and they say, please enter your RX number so we can pull up your information. What's going to happen is when you enter that RX number and press the pound key, what's going to happen is the bot on the other side of this call is going to go into the database and he's going to find your RX number, and then he's going to see your name by looking at the ID. Now that's the next big thing. We need to link our records with our people. Okay, so for one, we're going to look at the RX number here. It's going to be our primary key of this table so that we can call back upon it because we're going to need to. Next record we're going to call upon is we want to get the person who this medication is prescribed to. So that's where we're going to look to our people. So what I like to do when I'm creating my entity relationships, I like to go with the name of the table and then I do underscore ID. Okay, so whatever the foreign key is I'm calling out to, I want to put the name of the table that it resides underscore the field name. So in this case, we're calling out to the people table here. So people, and then I say underscore ID. And this is going to be our foreign key that will be called upon to get all of this information from this table. So when I pull up a RX number, I want to see all this information. I want to see the person's name. I want to see their phone number. I want to see their residence. I want to see all this information when I pull up their name so I can confirm this is my person I'm looking for. So what happens, I pull up the RX number. RX number is going to go, okay, the person's ID is this. Well, I'm going to call over to this table now. I'm going to say, hey, who has this personal ID? And then what's going to happen is all this information that is related that I called for now gets spilled back to our pharmacy record table and displayed in our application. So an application I designed, I'm trying to get I enter my RX number. Now I want to have the name of the person who that RX resides. Application is now going to say, go to this table, get this information, and return it. That's how it works. Now there are queries and select SQL languages. So select query languages will actually permit you to actually call out other tables when you write your commands. So I could say select star from pharmacy records where RX like such and such. But when I do that select star, I also want to call out, say, give me the information that is inside this table. Okay, so give me the names and stuff and return them to these fields so I can see them all. So because we're calling out to another table, we're calling that a foreign key. Another thing we're going to need for our people ID is we're going to want to call out for our doctor. So our doctor, he's going to reside in the people table as well because he's like a person record. Now he's going to appear as if he's just a normal individual on this table, but we're going to make a table that actually says what are the different types of people that we have stored. We have doctors, we have assistants, we have staff members, we have clerks, we have all kinds of people. So we're going to also call out for my doctor. So the doctor that's assigned, doctor. And we're going to put, for this one, because it is calling out to that same table, I'm going to put an underscore people underscore ID. Whoopsie. What did I just do? Did I just screw myself up? Okay, there it goes. It just zoomed down for me. All right, so we kind of have our doctor set up now. We're going to want to add even more things here, but this is also going to be another foreign key. Now let's go ahead and connect these two tables because we already have the information we kind of need to kind of start joining tables together. Generally, as I add fields that relate to other fields, I like to connect them right away. So it's like, oh shoot, did I forget to connect this with this? So what we're going to do here is first we need to look at a like a one-to-many relationship. So one-to-many relationship. We have one of something, and somehow the other table it's going to have many of. So which of these tables will we have only one of, and which of these tables will we have many of? So one person, are they going to have many pharmacy records, or are they going to have many or pharmacy records going to have many people? Honestly, it's more one person has many pharmacy records. Because think, as an individual with autism and epilepsy, I might have 10 records. And actually, it is true. I did have a history of autism and epilepsy. But in this case, we have a one-to-many relationship being the ID of people. So one person is going to have many pharmacy records. So connect those two together. Now, here's where it's going to get tricky. We have doctors. Now, if you think about it, a doctor is going to have many pharmacy records. Yeah. But many pharmacy records. Well, actually, no. No, only one doctor would be assigned to one pharmacy record. So that's going to be a different topic. I'm going to save that for later. A many-to-many relationship, and we'll talk about that here in a bit because that is something else that's going to be happening here soon. That's going to be the pharmacy pickup stuff, and that's going to be the next table we'll make. But again, with the doctor is going to be a one-to-many relationship because one doctor will have many pharmacy records that he will be listed on. So one doctor, many records. Got to remember that. One to many. Now let's go to where I was about to go with the doctor here. Obviously, people, they're going to be picking up their prescriptions on different days. So how do we manage that? We want to keep a record of every time someone picked up a prescription. We want to keep track of what prescription did they pick up. So what record did they pull from, and who picked it up? So who came to pick it up? What record did they pull from? What date was it collected? So, and this is going to get tricky because we are going to have what's called many-to-many relationships. A pharmacy record is going to be called upon many times. A person is going to have many times that they're going to pick up. So we have a many-to-many relationship here that's causing a collision, and now we need to handle it somehow. So what we're going to do is we're going to make a whole nother table here, and this table is going to be pharmacy pickup probably, or I don't know. Does anyone want to unmute and give an idea for a table name for this one? Because we're going to be looking at the records of picking up your prescription and what prescription did you pick up. So anyone want to mute and drop a idea? No one? All right. Well, let's just say we're going to call this pickups. Okay? Pickup number. That could work. I think we'll just go with pickups. How about that? All right. So, how about we play along here? Let's think of what fields should we have in this database so that we can connect our pharmacy records. We want to connect our people. What fields should we list? And again, go ahead and unmute and just give me ideas. You can even go into the chat and just list some ideas that you might have. Where is my chat up? So any ideas on what fields do you think need to be added to this table for us to create a record? The RX number. So, yep. RX name. No. So the RX name would be recorded in the pharmacy records. Date's good. So the date would be another one we're going to be wanting to look at. So let's go ahead and do that. So first off, we're going to also have a record number because we are calling out to other tables, and we're going to have a many-to-many relationship here. One, in a database, the tables usually they are numbered. So every time a record is created, a numerical value is usually added. But in databases, some database tables don't have that set up properly. So we do still want to have our pickup be recorded with an ID. So an ID record of the pickup. So we're just going to call this one ID. So it's the pickup record number. And this is going to be the primary key of our table. Next thing, like Bryant had said, he said we are going to need the RX number. And we're going to call out to the pharmacy records table. So we call out to the pharmacy records table on that one. Another one we're going to need prior to adding the date, we're going to want to think about our the person that is supposed to have picked it up. Okay, so who actually came and picked it up, just so we could say, like, well, a person by this name came and picked up your prescription today. So we're going to do another foreign key here, which is going to be the person that picked it up. So people, the recipient. Recipient would be the individual who actually picked it up, you mean, or the person that actually gave it out? Because that actually would be another one we probably want to keep track of, is who actually did the transaction, who was the clerk. So people ID. So let's go. Actually, we're gonna say the patient versus recipient. So yeah, recipient. That's a good idea. So recipient. All right, so we have recipient. Then that's calling out to the people ID table. So we can go ahead and connect these tables here. One pharmacy record is going to have many pickup records. So we could take the pharmacy the RX number. We could take that, and we could put that as our foreign key here, being our little pickup. And one thing you want to do is, right now we're going to be kind of conflicting on these two tables because of how the bars are. So what I'm going to do is kind of make this a little cleaner so that we can see where everything's going. There we go. Make sure they kind of jump over each other, okay? Don't have your lines matching directly, because then we're going to be like, okay, well, this is coming out of here, but where the heck's it going? So make sure every line has a straight through follow through. Unless if it's something like this where, yeah, it's the same value going to the same thing. But say this doctor was going back to here with a many relationship, then that's going to be kind of a problem. So the recipient, the people ID, so who actually picked up the prescription. One individual, they are going to have many pickups, most likely. So that would be a one-to-many relationship. Another thing we need to add, like someone had stated, was the date. We probably want to add a date so we can keep track of when was this picked up, so we can go back and track who or when did they actually come to the store and say, hey, I'm picking up for this. So I need to insert a new line. So let's go over here. I guess I can add more lines. That's a little different from what I'm used to. Oh, God. I shouldn't eat before I did this. And I just noticed we got that there. Okay. So another field, like we said, the date. And you can put time in a different field, but you can have the date in the field as well. So a lot of times in programming, date and time sometimes come out as the same field. So if I write a code right now, I'm going to call out for what time is it. Usually the command you run for the time in an application is actually call out for date. So you run the command date that's going to return the date and time in one solid string, and then you have to chunk it up and reformat it. So we're just going to say the date. This actually consists of the time as well. So we can say date dash or date time. So date time. So what was the date? What was the time? How you format in your database, that's up to you, because a lot of query languages can actually restructure the data. So someone says, I want it formatted like this. Well, as the query writer, you should be able to take that request and then take the value that you receive and actually transform it. And this was actually a test I had to do one time. I had to actually figure out how to actually convert a um a date string that had time in it, and the challenge was only return the time, not the date. And they wanted it formatted in a special way, completely different from how the time was originally listed. So I couldn't just go in and say, from this character to this character, return it. I had to actually restructure through some code. So it's one thing you need to know how to do. So we pretty much have our table. We have 3 tables here right now. Pickup, state time, that has all kinds of information on that. Let's go ahead and start adding another table. I'm sure a lot of people know in a pharmacy, you sometimes have groceries and other goods. Well, let's look to the grocery side of things. How are we going to handle groceries and other purchased goods that we can buy? So we can buy thermometers, we can buy toothbrushes, toothpaste, all kinds of stuff happens in a pharmacy. And one thing about pharmacies is what happens in the pharmacy doesn't always stay in a pharmacy, so be careful there. Nothing like Vegas. And I still kind of find that Vegas line being a old phony fiction fact. Because I've been to Vegas, and what happened in Vegas, the only thing that stayed was my money. um, all right. So we pretty much have relationships pretty much started and introduced, how to do things. Another thing we also have to consider when we're building our tables, now you should understand the basic fundamentals in entity relationships at least. But another thing that we have to consider is variables. So you've heard me say variables multiple times, but variables exist in databasing too. So you have strings, that's a type of variable. That's going to be a string. You have integers. Now that could be a float, a double, all kinds of different trouble can happen from that. So you do have that. You have date and time. That's a variable. You have there's just many different variables that can come from a database. So you have to be able to figure out what are these different variables going to be. So let's go through. We're going to kind of investigate here. I could have used a different table layout because we have the table name. You have the key being the foreign key or the primary key. You have the field, which is the name of the field. And then you have the type. What is the type of field that we're using? So integer, string, date, varchar. Generally, that's usually a string, but varchar, so varchar, many different formats of fields in a database. And that's also like why in Excel. Excel, this is currently a number field. And one thing that can happen in a number field is if I type in 5.00, what's going to happen? It just turns into a solid 5. That's because it's currently formatted as number fields. So if I wanted to do 0500, what's going to happen? It turns into 500. It doesn't save that 0. That's because these are number fields, integer fields. And even as a float, they're going to return that 05. How can I keep that 0 is we have to turn that into a string field or a varchar field. So I just right click, I choose format the field, insert format, where was format? Format cells. So I'll select format cells, buffers for a second. And then we have all these different formats we could choose. You have date, you have time, you have percentages, you have fractions, scientific values, which is that stupid E plus O2, which is freaking annoying nuisance. You have the text field, which is pretty much where our varchar comes in. So all these. We're just going to go with that simple text field. I'm going to hit OK. Now, if I add my 0, 500 that I wanted earlier, that 0 will stay. That's because it is a varchar instead of a um, integer field like I was saying before. So understand your different fields and how they can benefit and cause issues. So we'll just go through our chart here. Generally, you want to do this as you're creating your records. Think of like what everything is, but I didn't pull up this table right away because I was more focused on how entities work. So let's now look at our different possibilities. So first off, the ID. We'd want that to obviously be an integer, okay? I would never in my life use a name or some text for a primary key or a foreign key because it can be a massive headache in finding it in the end, okay? So having a number assigned is better. You're pretty much limitless, and you don't have to go through the hassle of being like, okay, so it goes Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, Romeo, blah, blah, blah. I mean, Whiskey, Tango, Foxtrot, do you really want to deal with that? WTF is what I really just said. So, Whiskey, Tango, Foxtrot, would you ever do that? Um, so what we could do is we consider primary key being a number, that should obviously be a integer. So we could say our primary key ID will be int, so int. And generally that's where we would go over here and we'd say int, integer. First name and last name, those obviously should be strings, or you could call them varchars. I kind of forget, I don't think string actually exists in database language. I think it is varchar only. Now that I'm thinking about it, I think it can only be a varchar. I don't think strings relate, but that's kind of how it is. Pharmacy records, same thing. RX number, we're obviously going to want that to be an integer. People ID. Now, this is kind of really important when you're working on your foreign keys and primary keys, and why I prefer always having them be integers. Your fields, when they're related, so if my people ID field and my pharmacy record people ID field, if they are two different types, so if one is a varchar and the other one's an integer, that can spell Trouble, okay? Trouble, that's what you're going to get. So what you want to do is make sure that those two fields are both integers, okay? Whatever your primary key is, make sure that whoever it's calls out to it, they have that field being the same exact type. I think database language you can convert during the querying process, but it'll lead to trouble at other times because you can't always see that. The people ID for the doctor, it's obviously the same situation. Same with the RX number and the pharmacy records. We're going to want those to be obviously integers. Date time. I know for a fact there is a date field in data language, okay? So in query language, there is actually a field type being date, okay? Date time. I do believe with the data analytics class, I don't know if you guys still get the Mirach's MySQL book. Mine is currently at my dad's house. I need to go collect my books back. But the Mirach's MySQL book, there is a page in there that relates to date and time. So I think it's an entire chapter because there's so much you can do with date and time in databases. But that's pretty much it in how entity relationships work. Before I decide to probably add something else to this workshop, because this was more kind of like learning the fundamentals to databasing, does anyone have any questions on how entity relationships work? Feel free to unmute or just raise a hand and I can unmute you. Just any questions on what we've done so far? So Bryant, you pretty much get everything? Any other questions? Like any questions at all? So, if there's no other questions, okay, do we need a doctor table? Honestly, that's kind of where I said, like, we can have our doctor being under the people ID stuff, okay? So we could kind of think of, we can add another field in here that references them as a doctor. So we could have people type. So if I go in here, I could probably say person type. And this could either be an integer or it could be a varchar, depending on how you want to record it. Probably you want to have, rather to save data, we could have everyone be referenced by a number or something. So if you're a doctor, you have a value of 4. If you're a person, you have a value of 0. If you're a clerk, you have a value of 1. You could go with that method, which is called an enum, I believe, enumeration, where you're taking a numerical value and assigning it to a variable. Type equals recipient, patient, doctor. Yeah, they're kind of all relating to the same field. It's just we're referencing them in multiple ways. I'm sorry, I didn't see that last one. Let me see if I can find my freaking chat window here. Okay, that last question I see from Jenny. Would there be a need to reference other pharmacies that would have filled other scripts for a patient? That would actually be a good idea because, I mean, sometimes you could think, say, CVS, they're going to have multiple pharmacies, but one pain is if you try calling that pharmacy that you want to pick up from, but your prescription was filed at another one, usually you have to say, yeah, well, I have my pharmacy at, or my prescription's with another pharmacy. It's another CVS hiding in Pickerington. Meanwhile, I'm trying to pick up from the city in Zanesville. Um, so usually the pharmacist, they'll ask you, hey, where is it at? Where's your pharmacy? Or I'm sorry, where's your prescription currently located? So it could be an option for when we have multiple locations, so multiple storefronts. So you could probably say, because most likely, I doubt every individual store has their own database. Most likely, all stores are calling out to one massive database that is hosted by CVS somewhere. So you would honestly have that one table that would be the pharmacy. So you have pharmacies. So there's a table called pharmacies, probably. So we have our pharmacies table. So pharmacies, not really how you spell it, but we're using lingo here. So pharmacies, you have the store number, so store ID. So we'll just say ID again, pharmacy ID, if we're ever calling it. But PK, okay, PK, and then we have city, state, zip, blah blah blah, all that information. And then what's going to happen is the pharmacy record somewhere in there. It's going to say what pharmacy is it currently held at. And then when the main doctor at the pharmacy, so the pharmacist, when he says, okay, I need to say how many records do I have assigned to my pharmacy right now? Well, he opens up his application, and the application, it's going to have a script in there that says, um, select star from pharmacy records where pharmacy equals whatever the pharmacy's ID is. So that kind of makes sense, Jenny? Or G9, I can't tell. I think it's Jenny. G9. Um, yes, it makes sense. I'm thinking along the lines of keeping tabs on controlling addiction issues. Yes. Yep. Okay. Thank you for correcting me on your name there. Um, Yeah, so that is a problem. Is pharmacies not communicating together? They're probably a small pharmacy isn't recording everything. Um, it would make sense if there was like a master pharmaceutical database out there in the world. There probably is by now. If not, then probably we can make one that can do this. And the pain is now all these pharmacies are sharing records with each other, which is scary. And there needs to be some intermediary party that these are all going to share. I know my dad's chiropractic office, he calls out to a database somewhere, but um honestly, if I owned a pharmacy, I'm going to want to have my own private database that only I can see and I'm not sharing out to the world. So, it's scary thinking of, but I mean, from a security standpoint, it is great practice, but from the customer factor, it is dangerous. And yeah, customers are gold. You want to be careful. It is data. It is personal data, so it is HIPAA. So you have to make sure you're following all HIPAA policies if it's a pharmacy. My dad's office, it was he didn't do pharmaceuticals. He did more chiropractic. So he was a doctor's office, and his database we had like we can't touch anything in. Like I actually had to secure that database really good. I haven't maintained it for a long time because he turned it out to another company, which that company is an intermediary. Yeah, the recording will be available later if you're questioning. Any other questions related to any of your relationship, or would you if not, we have the option to move on to another topic, or we can go ahead and call it a night. The other topic would be we can explore an existing database example. But that is up to you guys if you want to do that. So we can go. Like generally, my idea for the workshop was more just making entity relationships. You don't have to, Bryant. Like that's just the way I like to do it. I like to say the main reason why I do that is because it helps me find the table that I'm referencing. So the factor here using the pharmacy records RX number. It's just so I can be like, okay, so this field, when I do my query, it says this field is called the pharmacy records RX number. Well, I could be like, okay, so that must mean that it's coming from the pharmacy records table. So the master data is up there. Doctor people ID seemed like there was a doctor table. Yeah, sometimes I do that, sometimes I don't. I mean, how you do it is up to you. Just it's best to reference the tables in some way so you can crisscross them. Yeah, it's a wording thing. It's your wording lingo, how you use it. So like I like to generally lead with the table, but if it's if it's the same thing on a table, so if the same thing's referenced multiple times, sometimes I'll start out with how is this field unique to this table. So in the case of the doctors, we have the people ID. I probably could call this patient then people ID. So patient is the unique name to this table, but people is the table I'm calling from. ID is the field of that other table. How you do it is up to you. Um, this is just my crazy method of doing it. All right. So, would anyone want to actually explore like an existing database? And this is a public database. You guys can have access to it as well. It's not my private database. This actually belongs to W3 schools. Um, I see Jenny or Janine is interested. Anyone else? Anyone opposed? Go ahead, Bryant. If you want to unmute, you can talk. No. Okay. All right. Well, I guess we'll go ahead and continue for a little bit longer since we have some people that are interested. This is going to be more kind of querying in a way. So how to write a query. this is something I'll do here and there. I mean, I don't do querying during my day job, but I mean, I used to try to apply to be a query writer, and you can actually kind of see I've had a lot of fun playing with databases in my life. There's a lot of database designs I've made. We have like the Doctor's OS, which kind of relates to what we were doing. The Doctor's OS was kind of an idea for a cloud-based doctor's office software that it'd be more introducing the Internet of Things with a typical doctor's office. So you can kind of see how I kind of was structuring here. We had the client, which was the individual. And this kind of shows the provider's information. So one client, they had what office were they going to? This kind of was in my early days of designing, because I can already see so many issues wrong with this, and it makes me question: did I really design that? I did, but it was in my early days. But yeah, databasing, it's a lot of fun when you get into it and get used to it. It's a lot of learning and activities. My little library that was supposed to be like if you owned a whole bunch of books, it was going to be more like an online personal library lookup thing that say I'm trying to find information on a keyword. Oh yes, that's the another big benefit to this. You can look back at everything you did. Yeah, you got to start somewhere. Yeah, I started in the classroom. Let's say that the classroom. Once I got started with that, I kind of boomed, and I think I even said in the Discord announcement like how I was referencing Professor um, Gina Cooper for being my professor that I had in the class, and I said she'd probably tell you how, like, when I got started, I kind of had a big explosion after her classes, and I was constantly poking her for like more information. I was always craving more and more and more. I'm like, I don't want to stop. Give me more information. So it was kind of a big bang in my life getting started with that stuff. Um, and Lucid Chart, I've gotten deep into. Oh, yes, it is. You got that right. And that's why that's kind of why I also suggested her being the new professor in charge of IEEE. In fact, speaking of which, this is off topic. If you are taking any classes, DeVry IEEE is currently in need of a new counselor because the previous counselor, John Golsey, has officially resigned as a DeVry faculty member. So he can no longer be our representative. So at the moment, the student branch is without a counseling professor. So all I could say is if you have a professor um, who is teaching an engineering related field, or they say they're some sort of engineer, ask them if they are a member of IEEE. If they're a member of IEEE, ask them if they would be interested in becoming the DeVry professor. One thing is, if they say like they feel they'd be blind and they wouldn't know what to do, you could tell them that John Golsey, the previous counselor, he would help. And you also have Ian Oberdorf, who was a former student of DeVry, who can help. Um, and any professors that you get interested, you just have to tell them to email Bryant Farrow, okay? So write down Bryant Farrow's name and send any possible professor to Bryant. So, that note aside, let's go on to part 2 of this whole activity because you guys kind of seem to be interested in it. So, part 2, what I'm going to do is we're going to go to another website called W3 Schools, and it's really easy to find. All you have to do is go up in your browser, type in W3 Schools, and this is very, very handy to know. W3 Schools has been my go-to for all sorts of knowledge. Okay, anything database related, I use W3 Schools for databasing, HTML, CSS, which is also kind of an HTML type thing, JavaScripting, Python, SQL. All of this is all included um, in this website, and I think it's kind of a free website. So if you ever want to use this stuff, hit it because it's been very handy. I mean, you even see there's references to C Sharp, C, React, Node.js, R, and R is kind of a database language. If you're in databasing today, you need to know R. A lot of companies are asking for it. Git, Raspberry, all kinds of stuff. So this website is a very, very handy website to know. So generally what we're going to look for is the SQL today. We're going to play around with SQL. So if you go here to w3schools.com, there's a SQL tab. Okay, click on try it yourself. And in here, you can actually test writing SQL queries. So here's a nice little demonstration for us. We have select star from customers. So the star is saying select everything. Okay, so all fields. I want every single field that relates to this table. So I want all fields that are in the customers table. Now the where clause, what that's going to do is going to say the field being country must be of this value. So let's kind of look at what would happen if we didn't add a where clause. I'm going to erase the where clause from here. I call it a clause, but there's many different titles for it. So we're just going to select star from customers. We're going to take a look at 91 different records. So over here, these are all our tables that we have access to. We have access to a customers table, categories table, employee table, order detail, order, product, shipper, suppliers, blah, blah, blah. We have all these fields. So select star from customers. I'm going to hit the run. As you see, we have 91 records currently. So 91 records. And if you pay attention, we have the customer ID. So who is the customer? This is our unique primary key of our table. Then we have our customer name. We have the contact name. So who is the person that is responsible for this company? What is their address? What is their city? What is their postal code? What country do they reside in? So that's kind of what we have going on here. We have all these fields. Well, I want to know how many. I want to take a look at all my customers from a select country. I want to see all customers that I have that relate to, let's say, from Mexico. They're from Mexico. So what I would do, we're going to return. We got to keep our semicolon at the end of our query. So select star from customers, and then we say where. Okay, so where, and then we say what is the column name. So our column name is country. So where country. Make sure you are case correct. That I believe a lot of languages or a lot of database types, they are case sensitive. So make sure you are good on your cases. So capital C O-U-N-T-R-Y. Where country, and then say equal single quote because this is a string field. That's another thing. If it's a variable field, you don't have to add quotes. If it's a string field or some other crazy field type, you have to have the quote lines. Okay. Most likely, looking at postal code, you would kind of think that would just be a variable, integer field. But if you notice, some countries like the UK, they have a lot of letters and stuff. So this is kind of where you make your designs. So where country equals Mexico. All right, so select star from customers where country equals Mexico. I'm going to run that. And as you see, we now have a bunch of references to different customers that we have that reside in Mexico. I want to know where they're at in Mexico. Well, we could say, look at the city. City is Mexico DF. Postal code 5021, 5023, 2233, 5033. So we have, these are all our customers that reside in Mexico. Well, let's say I want to see, I'm doing an investigation here right now, and I want to know how many orders were made. Let me think here. Should we do orders or should we go with order details? Let's try that. Let's take a look at the order details table here real fast. Nope, that just has the order IDs, quantity, product ID. Actually, here's a nice little sample of a table with entity relationships. We have order detail ID, then we have order ID, product ID, and quantity. So right now, this one table being the order details, it's obviously calling out to multiple tables here. We have the order ID table, and we have the product ID table. So order ID, most likely, that's going to be calling out to orders here. And I'm sure right now, if we look for this 10248, if I look at orders, we look for 10248. Here we go. We have 10248 right in the first field here. So we have employee 5 is obviously who took the order. The customer was number 90, and the shipper was number 3. So for number 3, we could say who was our shipper. We could look at the shippers table. Shippers table, it was Federal Shipping is who sent it. So it kind of makes sense on the database thing. You kind of see how a real database kind of lightens things up. One thing I would kind of give you guys a challenge with is what we kind of learned today is go to W3 Schools, and this is optional. You don't have to do this. I haven't even done it yet. But go to W3 Schools and see if you can kind of come up with your own idea of how the tables are. Yeah, queries are actually pretty simple until you get deep into them, okay? So, but here's what I'm going to say. Today's workshop is more focused on designing an entity relationship diagram. Using this existing database, try to figure out how to make your own entity relationship diagram. Go through the different records of this database. If you have access to a database that you can go into and pull information from, go ahead and try mapping that database. Just imagine how the database might be mapped. If you have the ability to query onto a database, then try it. Go to that database, find the table names, and then select star from the table, write down every field in that table, and then go to the next table. In fact, let's kind of start that here. I just went over the order details. Our order details page. We have some information here. Let's go on my blank diagram. I'm going to break it off. I'll put our diagram on this side of the field. And then I'm going to put our sample database right here. So let's kind of make our database based off what we have here. So I'll clean off all this mumbo jumbo from this field. Okay. So we have a blank entity relationship diagram. First thing we'll do is we're going to look at the the order details table. And let's go ahead and go with more of this bigger field type. So let's play along here. First thing I'm going to do is we're going to obviously reference the table being order details. So first, how about we look at the order detail ID. Does anyone know, should that be referenced as a foreign key or a primary key? Primary? Anyone have any opposings, or do you all agree with Bryant there on it being a primary key? You both, Bryant and Janian, you are both correct. It is a primary key because it is going to be our unique identifier for this record. And any idea what the field type is? Would it be a integer, a float, or a varchar? It is an integer. So how about the order ID? So we have order detail ID, which is unique to this table. But now we want to go to the order ID, which actually carries even more data for us that we're going to probably be calling out to. So would this be a primary key, a foreign key, or neither? You are correct. It is a foreign key because it is calling out to another table at the moment. And integer or varchar? Later, I already typed it. All right. So order ID is going to be an integer, and it's going to be the foreign key. How about the product ID? Would that be a foreign key, primary key, or neither? Like, do you think it would have any information on the other side? Foreign key, primary key, or neither? It would be a foreign key because it most likely the product ID is going to be calling out to the product table. So it would be a foreign key. So finally, the quantity. Would this be a foreign key, a primary key, or neither? Primary key, foreign key, or neither? For quantity. I see opposing answers there. So it wouldn't be anything. So it wouldn't be a foreign key or a primary key. So quantity, obviously, it's going to be an integer. Yeah, that's all right. Kind of had you rushing. That was kind of the big test there. But yeah. So obviously, it's going to be neither because they are it most likely wouldn't be calling out to an order because a quantity. What do you think quantity would be? It's how many of an item we ordered. And generally, when I'm looking at this table, I kind of see because the same order ID is mentioned multiple times. I kind of see this being a result to a receipt. If you think a receipt's going to have multiple goods on it, well, the order ID is the receipt is the transaction number. Or actually, no, the order ID is order detail ID is what line on the receipt. Okay. Order ID is the receipt number, so the transaction number. The product ID is what was the item that was purchased. The quantity is how many of that item got purchased. So that's kind of what I see in this table. Let's go let's see what other tables there were. There was also the order ID, so the order table. So let's look at the order table real fast. So it's really simple to get to the order table. We just have to modify our query here. We're going to make it just say select star from order. And I'm sure we're going to get a fail here because I think the table is called orders. As you see, no table existed. But look down here, it's orders. So it's the orders table. So I'm going to go to orders. I'll hit run SQL. There we go. Now we have our orders that we're after. So this is a whole nother table. We're going to do the same thing again. Just to kind of stroke our brains and get some ideas on how these tables are working together. So this is our orders table. All right. In our orders table, the first field is the order ID. Primary, foreign, or neither? Primary would be correct because it is the primary field. Usually the first field is always a primary, so kind of pay attention to that. And obviously that looks like it would be an integer. So would these two tables have any relationship with just that order ID being known? So if we have this order ID, can these two tables talk to each other? Can the order table call out to order details, or can order details call out to the orders? Any ideas? We kind of look at, think of this. Order details has every item that's on the receipt. So I have a receipt here. I have 10 items on the receipt. Order details, every line in order details is one record. Orders is going to be saying who did I buy from. All right, so which table would you say is the one, and what's the many, and what's the field that's related between the two? So what field is the relative field? So what field in order details relates to the orders? So order details is one, and orders has many. And what's the field title that relates between the two? Just so you know, you don't have to be talking in the text in the chat channel. You can unmute yourselves. Yes, it would be the order ID. So order details, we're calling a one to many order IDs. So we have, for every order detail, it's going to have many orders. So we're going to have this order. Actually, hold on. That was backwards. The order is going to have many order details. So it's going to have, the orders is actually going to have more items or less items. So orders actually, we have one order, but it's going to be called upon many times in order details. One example was the item or the order ID 10248, which was the first order. So order number had many records related to it. So the order ID 10248 actually had 3 records related to it. So if I go back to order details right now, we'll see multiple 10248s in the order ID fields. So we'll select order details. So select star from order details, and I'm going to say where order ID equals 10248. And we'll run that. You see we have 3 records. So that's kind of where our one-to-many came in. For this one number, we have many records that appeared. Okay? And let me go back to the orders table again so we can finish going through that. Just make sure we have nothing else that relates in this other field. So orders, we'll run that. We had the employee ID. Employee ID obviously won't relate to this field at all. We already have these 2 tables pretty much related, right? There's no way they'd have a conflict at all at the moment. So I'd say we could kind of consider that these 2 tables are kind of done with communications. But let's just continue. We're gonna do one more table here, just so we can kind of play around with our any relationship challenge that we're doing right now. Order, date, and shipper ID. Okay. So at the moment, we still have several other fields that can be identified, being the customer ID. And I'm just going to go ahead and rush through these real fast. Customer ID would be a foreign key because it's going to be calling out to the customer's table to get the customer's information. The foreign key will call out to the employee table saying who is the employee that ran the transaction. Order date would not be a foreign or a primary key. Shipper ID would most likely be a foreign key, calling out to the shipper's table. So let's now look into about the product ID. So we're going to relate our order details to products. So we're going to have our products table. So let's go here. We'll try products and see if that table exists. I'll run that and see what we get. Okay, so we do have a products table. Well, our products table seems to have 77 records. So first field we have is the product ID. Just to burn your brains, obviously, what do you think it is? Foreign, neither, or primary? Usually. Okay, so yeah, don't get confused thinking that the first field will always be primary. But most databases, it would usually be a primary key. So yeah, obviously the item ID is going to be a primary key. It's unique to this table, and we already should know that obviously we saw that same field in order details. So what do we think should we do? Which one's the one and which one's the many? Yeah, products and order details. So you have a product is obviously going to probably be listed with many orders. So how would you kind of describe that? Which is the one and which is the many? Do we have one order detail for many products, or do we have many products for many details? Or would we have a many to many relationship? They're saying product equals one and order details is many. You are correct. So the product ID is the foreign key in order details. And when we looked at our order details compared to our products, we saw in order details, the product ID was listed multiple times. So obviously, the product is going to be purchased multiple times, so it's going to appear in many orders. Product name, that would most likely not be anything because it is a name. It's how we're identifying this one individual item. So you kind of consider the product ID as the barcode. Meanwhile, the product name is the Cheerios, or it's Fruit Loops or Fruity Pebbles. A lot of cereal. um, Supplier ID. Now this would be a foreign key. Why? We want to know who's the supplier ID. Obviously, going to be a foreign key. And I will tell you this. This is one thing I forgot to mention with primary keys and foreign keys. Only one primary key can exist in a table. Every table can only have one primary key. So any other key is going to be foreign or some other type of key. Okay? So you can never have two primary keys in a table because then that's going to cause a big conflict. Um, Let me add my other three fields here just as our records because I'm gonna save this and probably finish it up in the future if we don't finish it tonight. I think we'll give until 9 o'clock to finish this if you want. We'll continue doing this if you want to drop off for any reason. And thanks for staying and enjoying the workshop and giving it a try. Go try this at home if you want. If you want to stay and play along, please stay. We'll stay on until 9:30, continuing this table as far as we can get it. Category ID the unit. Now I'm going to guess the category ID has no relationship because I think that's more of a enumeration. I don't think there was a categories table from my thoughts. If I get rid of that S on there, we'll see that here in a second. Let's see if there is a categories table, but unit, obviously that's not going to be a foreign key at all because it's the text. Price, I would say a price is unique to an item, so it wouldn't be called upon for anything. You're welcome, Janine. Like I said, if you want to leave for any reason, go ahead. If you want to stay and try to make this whole table and learn more on relationships, then please do. Please stay. Um. All right, category ID. Let's see if we do have a category table. So I'm gonna purposefully fail here and making this. Okay, so there is a categories table. So we do have a categories table that we're gonna have to reference. So I'm just gonna put this being a foreign key because obviously the category table is most like or category ID is most likely gonna call it the category table. Um. How about this? We still have 4 of us. Who all would like to probably join me on Lucid Chart and do collaboration? So you have the option to where if I give you guys the link to this Lucid Chart, you can actually be on this Lucid Chart with me. It's just like a Google Doc where you can have multiple people working on the same document at once. This is your option. I'll go ahead and share this in um I'll share this to the chat group here. It'll be a link. And you'll have access to edit. So I'm copying the link here. I'm going to paste it. We'll see if you can get into it. You're also going to need to have the SQL table open. And the SQL table, what you're going to have to do, or I'm sorry, you're going to have to go to W3 Schools, choose SQL, and you're going to want to explore these tables, okay? So either you can write the query like I've been doing here, where I type in the name of the table, select star from table, and then I put it on here. So go ahead and try getting into it. Let me know if it fails you. Oh, I see Bryant got in. So pretty much this table's already been set up. What you could do is go to W3 School and choose a table that we don't have existing yet. So right now we have order details, orders, and products. Bryant, how about you try tackling the customers table? So just go to w3school.com, scroll down the list until you find SQL. Click the try it yourself. That's going to open up this page, okay? So go ahead and try making our customers table on your own. You don't have to do the same field format as I did, but if you want to kind of sample your variable type, so like in my case, this field is going to be an int. All you have to do double click on a field and it'll highlight for you. So if you want to change where it says entity, just double click on entity and it'll highlight, and you could change it. So go ahead and you try tackling the customers table. Anyone else want to try? Paste the link. Okay. Um. Yeah, I'll just do this. There you go. So click on that link. That should open up the this table. But I would suggest saving W3 schools. W3 schools helped me through college because I had many times I needed to reference some C# or some Java or something. It has everything. It's a great programmer's reference tool. If anyone else wants to join, go ahead and join. The more the merrier. So Bryant, while you deal with the customers table, I think I'll go ahead and tackle another table here, unless someone else joins. Um, Main way you can figure out your tables. Um, the table would appear up on the right-hand side of your screen. Because I have my screen split, I don't see that list. So what I do is I just get rid of the last character in the table name here. I hit the run SQL, and then it shows me the list of tables. So customers. How about I focus in the categories? I'll make us a categories table. Uh-oh. So I'll make a categories table here. Category ID. Let's see. Type int. Next one is the category name. That does not have a key. That's going to be a category. Name. Okay. And that is going to be a varchar. Variable character. All right. And the next one is going to be the description. That's going to be a varchar. Okay. Um, okay, let me see another table I can make off of. So we got categories. Another table. We don't have employees yet. All right. If you want to try figuring out how they actually relate to each other, so if you want to drag the lines like I've been doing, all you have to do is make a red spot appear and then just drag and place to where it goes. So the customer ID, that's obviously going to be going into, that's a primary key. So we'll say the orders table here. If you drag the little, go to the red spot here that I make, just press and hold and drag until you get to the spot that you want it to relate to, then release. Along these little arrow things that appear, you can go ahead and go through and make your, um, like adjust your things so that they don't intertwine with each other. Like right now, if I did this, these two items, you're not sure which one's going where. You're probably thinking the order's going here. But meanwhile, I want the customer ID actually going down here. So make sure you kind of adjust your little crow's feet connectors. I call them a crow's foot connector because you got a little crow's foot on the many side. But back to employees here. I'm going to go ahead and fix this field up. First name. I'd say that looks pretty accurate. Honestly, I would say there are no other foreign keys. So that's actually pretty good. I'd say that looks like a complete table. I didn't even see you typing that. I just said that straight off me looking up for a second. Um, this is one funny thing here. Um, Databases, they cannot hold graphical images. The only way for it to hold a graphical image is it's going to have to be a really, really long data line that holds the code of the image. Otherwise, you need to reference the file name. So, like in this case, this database, it was going by the pick. So we called out to the file title. So if I was to go into their file server right now and I looked up empid1.pick, then I'll see the employee's picture. So this would be a varchar because it is like a string, but the application that I make would have to be able to call out to this file, like this folder where all these pictures are being stored, and then find that one unique folder for me, and then display it. So that's kind of complex in our application. Brian, if you have another table you want to try tackling, go ahead. That any tables we haven't hit yet, and to find the name of the tables, if you're kind of have your screen like me, just erase it, or you kind of start trying to make the relationships happen on these tables because all the tables I'm making right now, I'm not putting their relationships yet. I'll go through in the end and just verify them. So if you want to try connecting the dots, anyone can join if they want. So it's not just me and Bryant. Everyone's welcome to participate. Okay. Let's see, what other tables have we not done? So we've done the order details, categories, customers, employees, products was done. So shippers and suppliers look like it's the last two tables. Two, four, six, eight. Two, four, six. Yep, so shippers and suppliers are our last two tables that would have to design relationships for. Alrighty. We're almost done here. Um, all right. Um, oops. All right. Brian, would you say you've done all the relationships that you think are necessary? You think you got them all fixed up? All right. So let's go ahead and review Bryant's work that he did here. First off, I think this bar here I did, which was the products to the order details. Like I said, one product would have many order details. And so that's why there's the one to many on this side. Brian, I saw you do the opposite where you went one order detail for many products. So that was incorrect there. Um, I believe orders to order details. I think I did that one as well. Yeah, so think of this with the one to many lines because I guess you might have probably gotten all these backwards. The one always has that single line. The many has the crow's foot. So a crow's foot means many because you have one, two, three lines. The single line, which makes that little cross, is the one. So one to crowfoot. So one crowfoot. So customer ID. One customer most likely would have many orders, I'm sure. So that is backwards as well. So a one to a many. All right. Employee ID. I doubt one order is going to have many employees, so that would actually be backwards as well. So that is a one to many. So one being employees and many being the orders. So one employee is a clerk. They're going to be fulfilling many orders. Suppliers. So products to suppliers. Let's take a look at that. So I'm pretty sure one supplier is probably going to have a lot of products. So that this one supplier, they're probably going to have 20 different products that they sell. So that's kind of going to be the one to many factor. So one supplier, they're going to have a lot of products that they'll sell. Mm-hmm. All right. Products to categories. So we have 4 or 5 categories and we have 50 some products. So this one is backwards. So this one would be we have about 10 categories, I believe there were, and we had a whole bunch of products. So if you think of the categories was like soda, it's a soda, it's a cereal, it's a fruit, it's a vegetable. So that's kind of where the categories was. So like if I go back down here to the categories option, you see we have beverages, condiments, confections, dairy products, grains, meat, produce, and seafood. So this was kind of Categories is more the enumeration connection, you could say. So categories made beverages be the enum of 1, condiments the enum of 2, produce the enum of 7. Shippers, I saw you do that one the way I would expect you to. So shippers is a one-to-many relationship. So one shipper is going to have a lot of orders. So that would be right. Suppliers, I fixed that one already. So I think we pretty much went through it all. I think we pretty much have all our relationships down now. So using this ERD that Brian and I just made, we can now kind of get a better visualization of our tables, and we can kind of now do our queries to find our stuff. So I'm trying to get my information here. I want to find a customer had called in today. They complained. They said that their order was for 4 of a certain item, yet they only got 2. Well, first thing I'm probably going to ask for is, what was your receipt number? So this is a little number at the top of your receipt. Can you tell me what that number was? I'm going to go in as customer service. I'm going to go to the orders here. And what I'm going to do in my orders table, I'll do select star orders like the sample says here. Select star from orders. Now I'm going to say, okay, can you give me your order number that you had? In this case, we're going to say we had their order ID was 10258. Okay, select star from orders where order ID where order ID equals 10258. All right, so let's go ahead and take this. We're going to run this. All right, so in my Excel table here, we're going to take notes here as we go so we can kind of solve our mystery of how many items was this customer supposed to have. And we can find out who was the employee that was responsible for it. So first off, the order ID they told me was 10258. 10258. Okay, customer ID. This was customer number 20. So we're going to write that down for now. We're going to get their information later. Customer ID of 20. Next up, we have our employee ID. And that was a value of 1. Our order date. So the customer said the customer was correct on their order date that they came in and picked up their stuff on. So I'm going to say they ordered it back in 17 in 1996. That's an old order for you to be calling in today, ma'am. But we're just going to say, like, we're back in 1996. I was only 6 years old then, so whatever. We'll just say that happened. Shipper ID was 1. So shipper ID was 1. So now, use my ERD. We're going to collect some information here. I'm going to put my table here to the side for a second. I'm going to now say, let's look for the items that were in this order. Okay, so we're going to look for the items that was in the order. So what items did the customer purchase that day? So we're going to go now to our order details. So we're going to select star from order details. Okay, and what do you think we're going to want to search for in the order details so we can get our customer's information? So what should my where clause be so I can get the items that was in the customer's order? So where product ID? No, we want to find we want to get all the information from their order. We want to know everything that they purchased on their receipt so we can confirm all their data. So right now we're going to be looking for the same thing that we just looked for in the previous clause, which was the order ID. So we want to call order details where the order ID is still the same order ID. So this was a number on the top of the receipt. So I'm going to run that. Okay, so we had 3 items in their order. And yet they're saying they got 2 of one of these items. Well, I could say, okay, so items you purchased was the product was number 2, number 5, and number 32. Well, I can't just tell the customer that. I'm going to have to go in and I'm going to have to pull this information, but that's going to be where we're going into the product ID stuff. So we'll have to take note of a product ID. We're going to ask them, because most likely on their receipt, this is in numerical order. Okay, so their receipt, most likely item 2, then 5, then 32, judging by how they checked out. So they checked out, this is the order on their receipt. I could say, okay, can you tell me which item in your list there, like was it the second one or the third one down was the problem? We'll say in this case that it was the second item in the list, which is product 5. So product 5 is the questionable item. Product 5 is our problem. So now we could probably say, okay, well, let me see what item this was. You ordered 65 of it. So you ordered 65 of this item, and it was product number 5. So let's go to my product table. I'm going to see what was this product that this customer was supposed to have a total of 65 of, but they only got 62. So 62 was the amount they got, but they wanted 65. So let's see. Product 5. So let's go to products table. Time is kind of cutting out here, so we got 2 minutes. So we'll just find this product that was causing a problem, and then we'll find the employee responsible so we can go confront them and say, like, look, you messed up this back in 1996, which is quite a long time ago, but we're just fantasizing here. Just imagine that we're in 1996. So select star from products. And we want our product ID is what we're going to look for this time, because we know the product ID is a 5. So we're going to look for, in products, we're looking for product ID, and it's got a value of 5. Okay, I'll run that query. And so some gumbo mix is what the problem was. Oh boy. So I guess they get 36 boxes. That's pretty interesting. 21.35 is the price. Category ID, category 2. I don't care about the category. I more care about who's my supplier and who actually was the employee. So product ID number 5. This person only got 62 of Chef Anton's gumbo mix when they were supposed to get 65. Okay, so we got that figured out. So this is our problem. Chef Anton's gumbo mix. All right. So after I do this next item, which is going to be the employee that was responsible, we're going to go ahead and call it a night because it is coming up on 9 o'clock. It is 9 o'clock now where I'm at. And that was kind of like the end time. I didn't want to go any higher than 2 hours. We'll go ahead and just find our responsible. I'm sorry. We'll go find our employee responsible, and then we'll call it a night. Okay, so finally, employee responsible. So we're now going to look into my employees table. Select star from employees. Where are my employee ID according to this table? Employee ID, we have the last name, the first name, and the birth date. So my employee ID was number 1. So employee 1 is the one that is responsible for this transaction. All right, I'll go ahead and run that. And so it was Nancy DeVolio. education includes a bachelor's in psychology. So she must have played a mind trick on them by my wild guess. She's also completed the art of the cold call. Ooh, she's a cold caller. I don't know why we hired this woman. And she's a member of Toastmasters International. Okay. Well, we could consider we're gonna probably have to go talk to this employee real fast and say, hey, so you there was an order that came back. They're saying that they got two of an item. Um, were we short stocked that day on this item, or what happened? So now we narrowed our investigation down. We're talking to our employee, figuring out what the heck happened. So that's kind of our data digging that we just did. We kind of mined for data. One other thing that you could do here as well. Say I don't care for everything. I just wanted to know what was their first and last name, just so I can go talk to the employee themselves rather than get all this other exclamations. For the select star field, I could put in quotes. I believe single quote actually. Select quote. Last name, and then comma, and then single quote again. First name. And then I believe this should have returned only the last name and the first name. Let me try that again. Last name. Let's see if this probably SQL might be a little different from what I'm used to, but run that. There we go. So select last name and first name. Now I just have her first and last name rather than getting all this other mumbo jumbo that I didn't care for. So I'm going to go have a talk with Nancy here and confront her, figure out what the heck happened with our order that went wrong so I can take corrective actions and write the report on it and then move on with my day. So with everything we learned for the day, any questions? Yeah, it's back in 1996. That was quite a jump. But any questions before we go ahead and check out? Helps a lot with your database class. I'm glad to hear. In fact, if you have any issues with your database class or you have questions and need help, don't hesitate to reach out. I'm always happy to help. Probably confront me through Discord. If you confront me through Discord, what I would suggest, and honestly, you could do this with any class, and it's kind of why I kind of made this one channel in Discord for us. The in Discord we have a channel. If I don't freeze. Not saving that file. Come on. Work Discord. There we go. Okay, so in Discord we do have a channel. Ask IEEE. I think I will I think I'll make another channel like this. And I'm gonna call it tutoring assistance, okay? So we're gonna have a new channel added here soon. We're gonna call it tutoring assistance. And what it will be is gonna be where either a professor or a classmate or anyone can come in and they can help you with your questions. So if you have a certain question on a certain topic, so say the database class, you have a question on you're having issues with this query, you're wondering what are you doing wrong. So I'm writing my query and I'm putting these quotes around the title. So list your query that you put in, and then either a fellow student in our group or probably even a professional will come on and we'll give you a response. Say, well, looks like you have your quotes here. Remove those quotes and try that. See what happens. So I'll go ahead and add that channel here in the next few days. You can watch out for this recording. This meeting was recorded, so if you want to share it with anyone or use it for your future references, go ahead. Have fun databasing, because databasing is pretty fun. So, any last minute questions before I go ahead and lock us out? All right, well, your silence is most intriguing, so I think I'll go ahead and end this recording and end this meeting. So, thank you all for coming out. Again, just reach out anytime through the Discord chat, or you can also email me. First name Ian, last name Oberdorf at IEEE.org. So IANOBERDORF at IEEE.org. Um, have fun with your classes, and I'm always happy to help you all. So, good night. And the recording's been cut.